Hi, this is Mr. Max with the last part of my series on set notations and Venn diagrams. This is part 5 of 5, and what I'm going to do in this particular series, I am going to do examination type questions. I have about 7 questions lined up that you can use for revision purposes. Right, so the first question that we have here, you have the universal set of integers between 4 and 20, with 4 and 20 obviously included. Then you have set A that are consisting of composite numbers. These are numbers that have more than 2 factors. And then the set B consists of multiples of 5 between 4 and 25. Right, so we are supposed to find the number of elements of the intersection of A and B. So what I do first, I first want to list the universal set so that I can know. So I have the integers, which are positive numbers here, whole numbers from 4 up to 20 listed for the universal set. I have set A, which consists of composite numbers. What you can see is there are no prime numbers in here. Okay, these numbers all have got factors that are more than 2 factors. For example, 9 has 3 factors, 1, 3, and 9, and so on. And set B consists of multiples of 5. So when you look at the multiples of 5, you only have 5, 10, and 15 from that universal set. So there is an overlap when you do Venn diagrams. So I have indicated in blue what they have in common, therefore also giving me the answers that the intersection, the number of elements, the members are just 3. Then what I want to find here is when you are combining set A and B, we are finding the complement, what is not in set A and B. So with respect to looking at your universal set, you can easily determine what is not when you join these two, what is not there. And quite frankly, you realize it's only the prime numbers that will not be there. That's how that particular question is done. Now, the B part of this question consists of a question that says that there are learners in the school that take part in soccer as well as netball. And 33 of these learners are playing this sport on the school team. And we also know that 3 don't play soccer, nor do they play netball. But then we have an unknown amount of learners who play both. So that is representing an intersection. So what I like to do is when I do my Venn diagrams, I like to put next to my set the elements or the number of elements in that particular set. So I know that 26 learners altogether will play soccer and 14 learners altogether will play netball. So what I also know is that X play both netball and soccer. So we represent by putting that X in the overlap in the intersection here. What I also know is that 3 learners do not play any of the 2 mentioned sports. So I indicated here on the outside of the circles inside the rectangle. Now, what I want to find this missing value, I will have to say 14 minus the ones that play both, and also 26 minus the ones that play both. That is how you complete this. So supposedly they tell you to find the value of X, therefore you can just add everything here and let it equal to 33. Okay, or you can also take the union of these two sets and you take away 3 and that gives you 30. So what I mean is in the next question they are going to ask you to calculate the value of X. You can simply add everything here and let it equal to 30, or you can add everything including the 3 and let it equal to 33. So that is the question I was referring to. So when I bring that back here, so you can have it next to you, and also the Venn diagram. So there are 2 ways, and I mentioned it briefly. So I can add everything, and this is just the union of the sets. I know that these 2 sets, when I add them, must give me 30. That is minus the 3 outside here. So when you solve that particular value, you're going to realize you're going to end up with a value of X, which is equal to 10. Or you can use that second method where you equate everything in the universal set to 33, everything that is everything here, and you equate it to the 33, you are still going to end up with the same answer. Question 2. There is a Venn diagram here, and it shows the number of elements in 3 sets. You have got set A, B, and C. So from here, we are told that the number of elements of all these 3 sets, you can also see it is not in a rectangle. It doesn't matter because there's no other element outside. So all of this should equal to 93. So it's very easy and straightforward, therefore, to find the value of x. So what you simply do is you add all of these values. And you have to be careful because you're going to have an x and a minus x. The x's will cancel, leaving you eventually with only one particular x. And we add all these numbers together, you're going to get 88. And from here, you can actually calculate the value of x. So our value of x is equal to 5. Now, the next part of the question, what I did here is I have now completed my Venn diagram where I have taken away those x's because I know that x is equal to 5. So now this in red represents the actual values. So when they're asking here for 1 mark, find the number of elements in set A, that means you will have to add the 15 plus the 10 plus the 5 plus the 5. That gives you 35 for that whole set A right there. And when they ask you to find the elements for set B, it's similar. You add all of these, as you can see, I indicated in red, and that gives you 40. And when they ask you to find the number of elements in set C, you add all of these again, and you get 50. Now, when they're asking you here at E to find the number of elements for the intersection of A and B, so it is this region right here. So it is that 10 plus that 5, which is 15. Right, I'm going to bring back my Venn diagram, still the same Venn diagram. I just clean it up a little bit so that it can be easier to complete the rest of the questions. So they are asking us here now to find the number of elements in the intersection of B and C, which is this region right here. So it is that 5 plus that 7, which is 12. Similarly, they're asking us to find the intersection of A and C. The number of elements there, it's going to be 10. It's this region here, the 5 plus the 5, which is 10. Now, what they're asking here at H is you are supposed to find number of elements when you join set C with set B. So ultimately, you add everything here. Or remember, all of these add up to 93, all right? Or you can take away 15 from 93. It still will give you the same answer, which is 78. The next question, you are supposed to add the number of elements that are in the intersection of A, the complement. They are not in A, where A and B. So let's go to where A and B are intersecting, and A and B intersect here. We know that. And this 10 plus 5, but we are not looking for this. We're looking for anything outside. So it will be this 15 plus this 5 plus this 33 plus this 7 plus that 18. Okay? Or you can just take away this 10 plus 5 from 93. You'll get the same. You'll still get the same answer. Right, question 3 here says 90 learners are asked which school clubs they attend. The D is for the learners who do drama, the M is music, the S is sports. Now, we have got, as I said, the way I like to do it, I have 39 learners who are doing music, 26 learners. I'll come back to this one, but let's first look at the 35 learners, they do drama. Now, this 26 is very important that I need to mention it. It's the learners who attend exactly 2 clubs. So if a learner is here, this learner is attending drama as well as music. If a learner is here at A, they attend sports as well as music. If a learner here is at B, they attend drama as well as sport. So what they are referring to, this 10 here, plus this 8A here, plus this B here should equal to 26. That's exactly what that means. All right, so we now have to calculate the 4 missing values. So I start with A and I put my A here. So I know that this whole set here should give me 39. So therefore A will just be, I take 39 and I subtract everything else that I have, and I now know that A is 11. Now that I know A is 11, I can now work with that 26 that I was saying. Remember I said 10 plus A plus B should give you 26. But now I know what A is. A is 11, so I can actually find that B. And when I find B, I find B to equal to 5. Now that I have B here, I can actually find C because I will take that set there and I will subtract everything from 35. So I will say 35 minus 10 plus this 5 plus B. But I know now from my previous work B is equal to 5. So C therefore is 15. So what I'm left with is to find the value of D. And in order to find the value of D, everything here, if I add everything here, now that I have, remember now you have your value of A. So what you do is you take, for example, your calculator. So you know that A is 11. And you know that your B is 5. And you know that your C is 15. So we're going to essentially add everything there. So you're going to add everything in here that you have, all right? And then you subtract that, and that is what this represents, the union of all these sets. You subtract that from the 90, which is the learners, the total learners that you have. And once you do that, you eventually end up with D equaling to 8. And that's how that particular question is done. So let me bring the Venn diagram back now after I have entered the values, and I will answer the questions that are following. This first one is fairly easy. It's asking how many students attend all three. That is that region there. All these learners here, they attend drama, they attend music, and they attend sport. So that answer is simply 5. Now, one club only. Here you must be a bit careful. One club only. If a learner is here, this learner is only doing sports. If a learner is here, this learner is only doing music. And if a learner is here, they're only doing drama. So this is the sum that we are looking for. So all these 51 learners together, they only do one club. They only take part in one activity. Now what they're asking us here is they want us to find the number of elements where set D and M are intersecting. So my D and M, it is this region here. So it is just going to be 10 plus 5, which is 15. And what they're asking us to find here is we need to find the number of elements. Now we know already the number of elements of D and M, which is 15, but the intersection of what is not in this particular set here. So what I did is I already know my 10 plus 5 comes here, okay, which represent this, and this particular elements here represents everything that is not in set S. This 15 is not in this set. This 10 that you see is not in this set. This 13 is not in the set. And lastly, that 8. So I'm looking at the intersection of those. What is keeping them together? And you can see I already indicated with black that 10 is the intersection, is the number of elements that are intersecting there. And that is how you solve that particular question. Question 4, again, a question that deals with students choosing subjects. As you can see, 37 of the students are taking physics, and 48 are taking mathematics, and 45 are taking biology. And then they tell us that 5 students are sitting for all of that. So what I do is immediately when you introduce that 5, it should be quite straightforward now that you have to take away that 5 from the information that you are given. We know that 20 is set for physics and math, so it's this region here. So I must take away 5 in order to find out how many will they be, because I cannot include these 5 already because they're already part of learners who are also taking the physics and the math. And they know that 18 is set for biology and for mathematics. So I must again take away the 5, because if you're not, you are now considering that remember, there's already 5 here. So this region here, it should be 5 plus 13 to give you that 18. And the same applies for the 12 learners that set for physics and biology. So the ones that set for physics and biology. Okay, the one that said for physics and biology, they are 12. So physics and biology, we have to take away because it's going to be 5 plus 7 that must give you that 12 learners that are doing physics and biology. Now they are asking you here to calculate the number of elements for the union. So all of these elements together. So basically all of the red ones, when you add them all up, and you will end up getting 85. Right, so I have, don't worry about these numbers, I'm going to get to them in a minute. So we have got three sets that we are supposed to find in the simplest form. So you can't solve these without having a sort of a diagram. So what I'm going to do is I'm going to write here a 1, a 2, a 3, and a 4. And it will assist you to answer this type of questions. So the first what I do here is I look at the intersection of A and the intercept of A, or the complement of A rather. So everything that I have in A is this 2 and the 3 here. So the 2 and the 3 is what I have here for A. And the intercept of what is not in A, and 1 and 4 is not in A. So there is nothing that is joining them. They are disjointed. Can you see that? There's nothing joining them. So it's just essentially an empty set, which we use this or we use that symbol. When we do the same for this union now, so I'm going to take again set A's value 2 and 3, and I'm going to put it there, and I'm going to join it with what is not in A, and what is not in A is 1 and 4. So the union, you just have to combine them. And when you look at 1, 2, 3, 4, they represent nothing but the universal set, everything that is inside the set. So you cannot solve this question without using a diagram like this. Now, when you look at C, so you have again the intersection of A and B, all right? So we are talking essentially about these three here, but we're going to combine it with whatever business is going on here. The A intercept the complement of B. So what I did is I have the intercept of the 2 represented by that, the union of, but I first put in brackets here, my set A is 2 and 3. This is what is in set A. The intercept I bring there. What is not in B? What is not in B is just simply what is not in B is 1 and 2. So once I look at what I have here, remember, I can come and clean this up a little bit. So if I work here, what I realize what they have in common here, they have the 2 that is in common. And because that 2 is in common here, that 2 is going to represent that intercept there. So the union simply wants us to combine it. Now, when you look at these 2 and 3 here, you realize it is basically nothing but set A. Okay, and that is how that particular question is done. And this is what we were looking for when you were supposed to do this question. So I'll suggest that you refer back to this, pause the video, and make sure that you understand this particular question. Right, this is a question 6 that says in a school of 145 students, and some they chose sports and music and drama, and you have another where they have combinations of so on and so on. So this question is similar like the ones we did before. So let me just bring in my Venn diagram here again. So you realize we don't know how many of the students are doing all three activities. That is represented by X, very important. But what I'm more interested in is how do I find this 12 plus X and that 31 plus X and that 57 plus X. So also you know how you find the 7 minus X and the 21 minus X and so on. What you find here, remember what I said in the previous example, we had a 5 here. So we subtract because 12 students chose music and sport. So it has to be music. This has to add up. This region has to add up to 12. So you must take away X here. And 7 students chose drama and sport. So the ones who chose drama and sport again, so you have to take away the X there, okay, because this region should add up to 7 and so on. So how do you find the rest that is not there? So let's bring in the ones who are only doing drama. So it's basically adding everything here and then subtracting it from 40. So once you do that, you're going to end up with that expression there. So you must be a bit careful when you're dealing with this expression here, that this minus changes everything inside the bracket. The second one is, how do we find the learners who are only doing, and this is a little small error. It should be 31 here minus x. So we should just make sure that we do not get it wrong. So it's 31 plus x rather, if you are subtracting. So this region here also, I've added everything here, and then I subtracted it from 64. And the same applied with the 76, where I added everything, and the difference is this 57 plus x. So that is how I find those particular values. So it becomes fairly straightforward. All of these things should be added now inside here and should be equated to 145. So when you add everything and you let it equal to 145, you realize that you're going to end up with an equation of 140 plus something x equals to 145. You clean that up, you get x is equal to 5. Therefore, 5 students chose all 3 activities. Question 7, similar question, but this one is a little bit straightforward, and I highlighted or underlined the word must take at least, which means there are no learners who are not going to do neither. All of them will do something. It's either they do 1 or they do 2. All right, so you have got learners doing physics, chemistry, and biology. The information is quite straightforward here because you are told to enter 8 take maths only. Okay, so maths and physics. So you put here in this region where maths and physics overlap. 5 take maths and chemistry. Maths and chemistry is 5. And 9 take physics and chemistry. Okay, and then the 7 take all 3 subjects, as you can see. And then you are told that the ones who are only doing maths is X, the ones who are only doing physics is X, and the ones who are only doing chemistry is X plus 3. So all of this stuff here, when you add them up, it must add up to 50, and that is what I did here. And you clean this equation, you get 3x plus 32 is equal to 50. And then when you divide, you will realize later on that x must equal to 6. But here's the thing, they want you to find x. We did that. But they are also at the same time asking you to find the number who are taking mathematics. So we go to the set of mathematics. So we know this is 6. So it has to be this 6 plus this 8 plus this 7 plus this 5. Learners who are doing mathematics. And that is what you do here to find the particular answer of 26. Well, this brings me to the end of my presentation. So again, you can join my grade 10 classes where you will find a PDF document of this particular worksheet that I have handed it out. You can print it out and then you can attempt to solve the answers. Look at the video again to see how you are supposed to do the answer questions. You can click the subscribe button for you to subscribe, share it with your friends, make sure that we all get on board. There's going to be a lot of videos. Our next series I'm going to do is based on algebra, and don't forget to click the notification bar on down there, that bell there.